Hi students, problem number 27. A long conducting wire carrying a current I is bent at 120 degree. The magnetic field B at a point P on the right bisector of the bending angle at a distance small d from the bend is to be determined. So I have taken a wire A, B, C. A long wire is taken, it is bent at the point B such that the angle ABC is equal to 120 degree. So angle ABC is 120 degree and exactly half of that bisector, okay, half of 120 is 60 degree. So P is a point which is located from the point B at a distance small d. So BP, okay, the distance BP is equal to small d, and the line BP is bisecting that 120 degree into two equal halves, 60 and 60. Then I project the point P perpendicularly on the portion BC. So P is projected vertically on BC at a point R. So PR is a perpendicular, okay, to BC. Similarly, the point P is projected vertically on AB, which meets at the point Q, such that PQ is the perpendicular distance from AB and PR is the perpendicular distance from BC. Now you can see the right angled triangles PBR and PBQ, so that these two angles are 90 degree and already these two angles are 60 and 60 because PB is bisecting 120 into two equal halves. So the third angle of these two triangles must be 30 degree. 30 degree. Okay. Now what is the perpendicular distance PR? You can see that the perpendicular distance PR must be equal to the perpendicular distance PQ, and that is taking the symbol small r. I want to find an expression for small r, which is the perpendicular distance from where? From the point P to the conducting portion BC and AB. So I have to express r in terms of small d. So I will take in the smaller right angled triangle PBR, okay, in the right angled triangle PBR, what is the cos of 30 degree? I want to find out. So what is cos 30 is equal to adjacent side PR, okay, adjacent side PR divided by hypotenuse PB. So this is the PB. So cos 30 is equal to what? It is root 3 by 2. So root 3 by 2 is equal to PR. PR is equal to the perpendicular distance, okay, PR is equal to small r. So this is small r divided by PB is equal to D. So this implies r is equal to root 3 into D divided by 2. So r is the perpendicular distance of the point P where we have to find the magnetic field. This point is at a perpendicular distance of small r from the straight portions BC as well as AB. Okay. Now you see that at this point B, okay, what are the two angles subtended? You see here the point B is subtending an angle theta and the point R subtends an angle 90 degree. So this 30 and 90 are the two angles subtended at the point P by the end point, one end of the conductor B and the other point R. Therefore, the magnetic field B or B1 due to the first portion BC. B1 is the magnetic field at the point P due to the portion BC. So this is due to the portion BC. This is equal to mu naught into the current I divided by 2 pi into the perpendicular distance R into sin theta 1 plus sin theta 2. Okay, this is actually sin theta 1 plus sin theta 2. If you include means then this term should be 4 pi R. In the general expression we have taken this is 1 plus 1 2, so that mu naught I by 2 pi r we have derived for the straight conductor which is infinitely long. The two ends of the conductor are meeting only at infinity, but this is not infinite conductor, it's a finite conductor. Therefore the general expression I have written mu naught I by 4 pi r into sin theta 1 plus sin theta 2. Okay, so B1 is now equal to, okay, B1 is now equal to mu naught into I divided by 4 pi into r in terms of d. I am going to express root 3 d by 2. So this is r, let it be root 3, okay, root 3 by 2 into d, and in place of sin theta 1 I am going to substitute what here, theta 1 is 30 and theta 2 is 90 degree. So this is first one is sin theta 1 is sin 30 plus sin theta 2 is sin 90 degree. Okay, now you bring this 2 to the numerator. Before that 4 by 2 if you want you can cancel also. So I will write mu naught, this is mu naught into I divided by this 2 and 4 can be cancelled 2 times. So this is 2 pi d into root 3. So into root 3. Sin 30 is 1 by 2. So this is sin 30 is 1 by 2 plus sin 90 is 1. So 1 plus half is again what, 3 by 2. So that this is now equal to mu naught into I divided by 2 pi d into root 3, okay, into this 1 plus half is what, 1 and a half, that is equal to 3 by 2. So this is now 3 times mu naught I. So this is equal to 3 mu naught I divided by 2 into 2 is 4, okay, 4 into root 3, okay, 4 into root 3 into pi d, pi into d. Now this 3 divided by root 3 is what again? 3 is root 3 into root 3, is it not? So I will write here B1, okay, B1 is now equal to root 3 times mu naught I, okay, root 3 times mu naught into I. So this root 3 get cancelled, divided by 4 pi into d. So this is what, 4 pi into d. Okay, now what is B1? B1 is the magnetic field at point P due to the current carrying portion BC. At the same point P, the magnetic field B2 produced by the current carrying portion AB must be the same as B1. Is it not? B2 also should be equal to what? So this must be also equal to the magnetic field B2 due to the portion what? AB. Due to the portion AB also the same field only will be produced. Therefore the net field is what? Therefore the net magnetic field at P must be equal to twice this root 3 into mu naught I divided by 4 pi into d. So it is twice. So this 2 and 4 can be cancelled 2 times. Therefore the net magnetic field at P must be equal to root 3 into mu naught I divided by 2 pi d. This is the net magnetic field at the point P. Okay, which is the correct option? Let us see now. Root 3 times mu naught I by 2 pi d is the right answer. So option D must be the correct answer. Therefore option D is the correct answer. I hope you have understood well. Fine. Hi students, question number 28. If a steel wire of length L and magnetic moment capital M is bent into a semicircular arc, the new magnetic moment is to be found. You can see here, this is a steel wire of length L and the two end points are having a pole strength small m. So the magnetic moment, okay, the magnetic moment capital M is equal to the pole strength small m into distance between the two poles. That is m into L. Now such a long straight wire, steel wire, is bent into the form of a semicircle. See here, semicircle of radius r. So that the total length L must be equal to now half the circumference. So here L is now equal to pi into r. So this implies small r is equal to what? L divided by pi. So small r is equal to L divided by pi. Now in this semicircle, the two end poles are having a pole strength small m. And what is the distance between the two poles in the new formation? That is equal to r plus r is equal to 2r. So the new magnetic moment m dash I will take. M dash is equal to the pole strength m into r plus r is what? 2r. So this is equal to pole strength m into 2 into r in terms of length is what? L by pi. So this is equal to what? L divided by pi. So this is now equal to 2 by pi into m into L. So m into L is equal to capital M. Instead of this m into L, I am going to substitute capital M. Therefore, the new magnetic moment is what? M dash is equal to 2m divided by pi. That is the new magnetic moment of the semicircular loop. So which of the following options is the correct answer? You see, option C is 2m by pi. Therefore, option C is the right answer. I hope you have understood.